All right, so in the last video we looked at some coordinate geometry with a triangle. Now we're going to take a look at a four-sided figure. So we've got a four-sided figure. We have four coordinates, R, S, T, and U. And we want to know, is this four-sided figure, is this quadrilateral, a parallelogram, a rectangle, a rhombus, or a square? So we have to make sure that we remember and recall, it's been a couple of months, what each of these shapes has that's special. So parallelogram, the opposite sides are parallel, hence the name parallelogram. The opposite sides are also congruent. Those two things are definitely true, but that's true for all four of these shapes. A rectangle's opposite sides are parallel, and a rectangle's opposite sides are congruent. A rhombus's opposite sides are parallel and congruent. A square's opposite sides are parallel and congruent. And so we have to look at the special cases for the rectangle, rhombus, and square, because if we just say opposite sides are parallel and congruent, that could be any of them. A rectangle specifically has four right angles. We talked about right angles in the last video, dealing with a right triangle. Same idea is going to apply there for rectangles. Squares also have that. Squares, four angles are right angles, and so that idea is going to work for both of those. What makes the square so special is not only does it have the four right angles, but all four sides are the same. All four sides are congruent, and so that will tell us if we have a square or if we have a rectangle. A square would have all four distances being the same, whereas a rectangle wouldn't have all four distances being the same. A rhombus has all four distances being the same, but the slopes are not necessarily going to be opposite reciprocals because a rhombus doesn't have 90 degrees. So you've got different things that you have to look at. The bottom line is, as you're doing these, you need to look at a bunch of different things. So the first thing that we're going to do to determine if it's even just a parallelogram or not is we're going to look at the slopes. Now, the slopes don't have to be opposite reciprocals, but the opposite sides have to be parallel, and so what that means in order for us to have a parallelogram is that we need two matching slopes. So we're going to have to find all four slopes, and so let's do that first. And so I'm going to just label that this is slopes. Let's do it in a different color. Let's go red. We'll go red for the slopes. And so we have to find all four of the slopes. You can't cheat on this. You can't say, well, I'll just do two of them and everything's fine. It could be that two sides are parallel and two sides are not. That would make it a trapezoid, which is not one of our choices, but it is a possibility in real life. And so we have to do all four. And so just like we did in the slide with the triangle, we're going to do all four slopes with that slope formula. So with RS, I'm going to use 8 and 5, 8 going first and then 5, and then we'll do 2 minus 1. And when we calculate that slope, we get 3 over 1. You can leave it as 3 over 1, or you can just call it 3 either way. That alone tells you nothing outside of the slope of RS. Then we move on to ST. And I'll find the slope for ST. So using its y values, I'm going to go 4 first, so 4 minus 8. And then I'll use the x values, 8 minus 2. And when I work that through, I get negative 4 over positive 6. And I'm going to put on the big boy pants and reduce that to negative 2/3. You should always put on the big boy, big girl pants and reduce. And so we get negative 2/3 there. I knew that those two wouldn't be the same because RS and ST have to be next to each other, right? They share the letter S. Sides that are next to each other can't be parallel because they intersect. That hopefully makes sense. From ST, we're going to move on to TU. And to find TU slope, we'll use their y values for T and U. And I'm going to start with the 1. So 1 minus 4. And in the denominator, I'll have 7 minus 8. So when I do that work, 1 minus 4 is negative 3. 7 minus 8 is negative 1. The negatives reduce, so that's really just positive 3 over positive 1, which you could write as just 3. RS and ST, we notice right away, are the same. They're both 3. That tells us that RS and TU are the same. That tells us that RS and TU are parallel. Does that make us a parallelogram? No. That's only one pair of opposite sides that are parallel. The other sides might not be parallel, and again, that would make it a trapezoid, not a parallelogram. So I can't cut down on the work. I can't shortcut this. I can't cheat. You got to do all the work. Now I have to find the slope for UR. And when I calculate that slope using their y values and x values, I'll start with their y values of 1 minus 5, which means my x values I'll have to do 7 minus 1. So when I do that, 1 minus 5 is negative 4, and 7 minus 1 is positive 6, and I put on my big boy pants and reduce that to get down to negative 2/3. OMG. G, I see that that slope matches the slope for side ST, and so that tells me I have two pairs of opposite sides that are parallel. So that information right there tells me at least, this is not my final answer, but at least I have a parallelogram. Let's do that in orange. It's definitely at least a parallelogram, but it could still be a special parallelogram. So I can't say that that's it and I'm done, because I still need to test to see if I have a square or rhombus or rectangle, because this information could still be a square, could be a rhombus, because all of them have opposite sides that are parallel. So I know parallelograms on the table, but I don't know about the other four special types of parallelograms. So I need to evaluate that. So how do I check to see if it's one of the special parallelograms? Well, we actually already can eliminate a couple of them. Rectangles and squares have have angles that are 90 degrees. So what does that mean? If the angles are 90 degrees, then the slopes should be opposite reciprocals. Well, the slopes of sides that are next to each other. So when I look at sides next to each other, like RS and ST, or like ST and TU, or TU and UR, the ones that are next to each other, if I have opposite reciprocals, then I automatically have a square or a rectangle. I'll have to do more work to determine which. But in this case, I know I don't have that, because 3, oops, I didn't want to draw a line through that, I wanted it highlighted, 3 and negative 2/3, those are not opposite reciprocals. If that was negative 1/3, they would be, but it's negative 2/3. If I flip negative 2/3 over, it doesn't become 3, it becomes 3/2. Same thing with the negative 2/3 and the 3. Those are not opposite reciprocals. Same thing with the 3 and the negative 2/3. Those are not opposite reciprocals. Same thing with this negative 2/3 and this 3 up here. Those are not opposite reciprocals. You have no opposite reciprocals, so that gives me even more information. So let's get that down onto our screen. All right, so like magic. First, it is a parallelogram again, because the slopes of the opposite sides are equal. It is not a rectangle or a square, since the adjacent slopes are not opposite or reciprocals, are not opposite reciprocals. If they were opposite reciprocals, then we wouldn't be able to determine if it's a rectangle or a square yet. We're going to do another step next that will determine that. But we would know for sure it's one or the other, and then when we do our next step, we would be able to determine which one specifically it is. So right now, I'm down to a parallelogram or a rhombus. When you do the slopes, you will always, always, always eliminate at least one of the choices, because the slopes might not be equal. If the slopes aren't equal, then it's not a parallelogram. If the slopes are equal, it's a parallelogram. If they're not opposite reciprocals, we throw out rectangle and square. If they are opposite reciprocals, then everything's still on the board. So how do we figure out whether we have a rectangle, a rhombus, or a square? Or in this case, how do we determine if it's a rhombus or not? To do that, we have to do some distances, just like we did on the last slide with the triangles. So I think I can squeeze the distances in here, because the nice thing is we don't have to do all the distances. So let me divide this out here. I'm just going to throw a, nope, that's not what I wanted. That's the one that I wanted. I'm just going to put a little line here. And so now we'll take a look at some distances. I'll do the distances in blue. I don't have to do all 4 distances. All I need to do is look at any two adjacent distances. The opposite distances have to be the same. I automatically know it's a parallelogram. Once we have all 4 slopes checked off, we're guaranteed to have a couple of matching distances, and I'll do that at the end. But you only need to look at 2 adjacent distances. So I'm going to look at the distance RS. You can pick any 2 that you want as long as they're adjacent. So RS, I'm going to start with. I'm going to find the distance for RS using our distance formula that's in our last video. We'll take 2 minus 1, that's our x values for R and S squared, plus 8 minus 5 are our y values for R and S, and we'll square those. And when I work that through, it's simple. 2 minus 1 is 1, so that's going to be 1 squared. 8 minus 5 is 3, so that's going to be 3 squared. And that works out to be the square root of 10. You can leave it as the square root of 10. If you want, you can come up with the decimal equivalent, which is 3.16. That alone doesn't tell me anything. I need to pick another side. Now, If you were to pick the opposite side of RS is TU, TU is going to be that distance. In fact, let me do that real quick just so you can see that that is definitely, absolutely 100% true. If we do the distance for TU, our x values are 8 and 7. So 8 minus 7 squared, the order that you put them doesn't matter. The y values, are 4 and 1. So we'll have 4 minus 1 squared there. And if you do that, you end up with 1 squared plus 3 squared, OMG. That's going to end up being the square root of 10 as well. You do not need to do this. So I'm going to cross it out in the yellow. I just wanted to prove to you that they are indeed the same. They always will be as long as you've done the slopes already up top. So that doesn't help me finding the opposite side. I need an adjacent side. So how do I know what's adjacent to RS? Well, it has to use one of the same letters. It doesn't matter. So I can go RU or I can go ST. I'm going to go ST. So when I find the distance for ST, this is going to tell me whether or not I have a rhombus. So using the x values, I've got 8 minus 2 squared, plus using the y values, I've got 8 minus 4 squared. Order doesn't matter when you're doing the distance formula at all, as long as you keep x's with x's and y's with y's. So that's going to work out to be 6 squared plus 4 squared, and if you do that work, that's going to work out to be the square root of 52, which is 7.21. In order for you to have a rhombus or a square, which is a rhombus, all the sides have to be the same size. By getting ST, I notice that ST is not the same size as RS or TU, so this is not a rhombus. Since I know it's not a rhombus, and up top by doing the slopes, I know it's not a rectangle or a square because it's not 90 degrees. The only thing that it is, it's either a parallelogram or neither, but we already proved it was a parallelogram by doing the slopes, so this is a parallelogram. This is, can't write today, this is a parallelogram. Guaranteed. That's all that it is. It's not a square, it's not a rectangle, it's not a rhombus because it doesn't fit those categories. So when you're testing these out, I'm going to put a homework assignment up here. When you're testing out triangles from the last video, you have to do all 3 slopes and all 3 distances. When you're doing the parallelogram, rectangle, rhombus, or square, you need to do 4 slopes and 2 distances. You have to do that. You could actually flip-flop it. You could do the distances first if you want and do 4 distances and 2 slopes, but you must have 4 of one and 2 of the other. Okay, so we need 4 slopes and 2 distances, or I need 2 distances and 4 slopes. If I don't have that, I can't give you full credit, so make sure you're doing the appropriate work. Okay? And then you'll be able to determine what type it is. If it's a triangle, you got to do all 3, slopes and distances. So your homework assignment for this, the practice that you need to do, is going to happen on page 539. We're going to do problem 6, 7, 18, 19, 20, and 21. Now, one last thing that I want to caution you on with the 4. With the 3, it's no big deal because you have to do them all. But with the 4, you have to be really, really careful. Notice what I didn't do. I didn't do RT at all. Nowhere do you see RT because RT is a diagonal. You don't want to do that. They will always list them in order, RSTU. You may even want to graph them, and so you can make sure you don't do the diagonal. If I were to graph these, I'm not actually going to graph them, but we would have like R here, S here, T here, and U here. So there's our 4-sided figure. You do not want to do the diagonals. You don't want to worry about RT. You don't want to worry about US. So make sure that you are only doing the sides that are appropriate. Okay? So do that assignment for me and turn that in, and you'll get credit, and that'll help you with that 10% grade boost.